thanks again for coming to my second talk. It's one of the topics I like the best of all the topics I talk about. It is the masterful design in the living world. Now, just to give you some background, I did do a real science doctorate at an accredited university, so don't tell anyone say there aren't any real scientists who believe the Bible, because I've written published papers in my own field of spectroscopy and high-temperature superconductors, including a paper in Nature itself, which is supposed to be the most prestigious journal they have. So I've certainly done some real scientific work that even the secularists have to acknowledge. But about the design aspect of things, what we see really is a clash of belief systems. It's actually not science versus religion, but basically the scientific support for one religion versus the scientific support for another religion. To give you an example is Scott Todd, an immunologist, who said even if all the data point to an intelligent designer, such a hypothesis is excluded from nature because it's not naturalistic. And it doesn't sound like objective reasoning to me. He's already made up his mind that there's no such thing as a designer. Well, the Apostle Paul had a different viewpoint. He said the invisible things of God from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so they are without excuse. So people have no excuse when they go before God on Judgment Day to say, I didn't have enough evidence. According to this, they have plenty of evidence. They've got no leg to stand on. Now, here's a question, though. How do we know things have been designed? Well, for one thing, you have oodles of correct components, like this jet plane here. But you realize that a jet plane is made up 100% of non-flying parts. So how can it become a flying machine? How do I manage to get here from Australia in something made of non-flying parts? Well, the answer is that they are also organized correctly. And when you have organization, you know there is an organizer. That's pretty straightforward, real science based on observations. But what the evolutionists will sometimes tell us, that all you need for order is a flow of energy through a system. Yeah, that should work quite well. A bull in a china shop. Well, actually, on Mythbusters, they show that bulls are much more sensible than the saying would have us believe. They actually avoid the china. But you get the idea that raw energy destroys things. But if you harness the bull to a generator and use the generator to drive a potter's wheel, then you could get order coming from the bull's energy. But the point is that this using machines designed to harness this energy. It's not raw energy. Raw energy destroys things. And to give you another example, as a frog in a blender, now when you turn the switch on, you add energy to it, right? So what happens when you add energy to the frog in the blender? You get a frog smoothie. So why did the frog die here? It's because it was disorganized. You see, all the components are still there. But if I left this going for millions of years, you think a frog's going to hop out of there again. No, energy doesn't do it, because you haven't got the organization. In fact, not even a simple germ will grow in there. And that's why you can eat canned food safely. You know, what you have with your canned sardines or whatever you have, see, all the components necessary for life are in your canned sardine. But if you sterilize and seal it, it's perfectly safe to eat for a very long time. And the only way it gets contaminated is if the seal is broken and it got in from outside. So this is real science, that life comes only from life. It's called the law of biogenesis. Because let's face it, the can of sardines has far more chemicals than any primordial soup could ever have. And yet no life will form in there. So let's see why this is. Even if the simplest germ couldn't form in a can of sardines, it's because living things are incredibly complicated. I mean, you think of even a complicated jet plane. Well, living things are far more complicated than our man-made machines, because living things can reproduce themselves. Well, think about how complex a machine must be to be able to copy itself. Well, think of your photocopier. That's complicated. But a photocopier just copies documents. It doesn't copy itself. But living things can copy themselves. So they are far more complicated than anything we could possibly invent. And one non-Christian called Michael Denton, he talked about what it would be like. And this is a long time ago, so far more has been discovered since he wrote this. He said, to grasp the reality of life as it has been revealed by molecular biology, we must magnify a cell 1,000 times till it's 20 kilometers in diameter and resembles a giant airship. What we would then see would be an object of unparalleled complexity and adaptive design, a world of supreme technology and bewildering complexity. I'm going to show you one thing which was discovered after Denton wrote this. It's called the ATP synthase motor. See, what we have here is it's a very important machine because it makes a molecule called ATP, which is the energy currency of life. The people who discovered this, the motor won the Nobel Prize for it in 1997. And the point is, ATP is vital for all living things to exist because it provides the energy for all your biological processes. And cyanide will kill you because it stops ATP being made. So I hope that gives you an idea of how important ATP is. But now we know it's made by this motor about 10 nanometers across, or you could say 100,000 would fit side by side into a millimeter. So it's the tiniest motor in the world. And let's see it in operation now. Just try and get the motor working for you. It's actually going at about 10,000 revs per minute. But what this actually is actually an electrically powered motor. It's powered by positive electricity, and it's got a reducing gear here. So it's got, say, 10 rotations from here make 3 rotations here, and it's a reducing gear which makes it super efficient, and every rotation makes 3 ATP molecules. And it's going all the time because your body makes its own weight in ATP every day and consumes it. So you can see there must be lots of these things going on. I mean, your body would have 100 trillion cells, but each of your cells has thousands of these motors working to produce that vital ATP molecule. There are also many other amazing things, like proteins to get to the right place in the cell. They actually now are known to have address labels. So unlike the US Postal Service, the proteins get to the right place in the cell. They're not government run, that's probably why. But also, not only do we have these amazing machines and living things, we also have the information to build these machines, the recipe for them. And this is the molecule DNA, which looks like a very complicated molecule. But in fact, what this is doing is storing letters which codes for all the proteins of life, you see. So not only do we have this amazing machinery, we have the amazing blueprint for it. So you imagine going and finding some sort of lander on Mars. You can clearly see its design, but what would really clinch it is if it had the instruction manual in the glove box. This is what we have here in the cell, the instruction manual, as well as the machines that we have. To think about it, you see, what we have are these letters of DNA, 4 different types of letters in DNA, and they're read in groups of 3, and every 3 DNA letters codes for 1 protein letters. Okay, so, I mean, see, in a book we've got the information coded in ink molecules on paper. But the information is not the ink molecules. If you don't believe me, spill some ink and see if you get the works of Shakespeare out of it. No, it's the way the ink molecules are arranged into the letters and the words and the phrases and the sentences and paragraphs, okay? But you could have exactly the same information with knots on a piece of string and Morse code. And exactly the same information on a magnetic hard drive, magnetic on and off patterns. As long as you have the right code, you could have the same information. And in theory, you could have this information on DNA as well. In fact, as has been said before, each of our 100 trillion cells has about 1,000 books worth of information. So it's an incredibly compact information storage system in our DNA. So that's one thing. You need the information and the code and the message, you see, because whenever you have a message, you know there's a message sender. A program requires a programmer. Books require an author. This is exactly what we have with DNA. But we also have the decoding system, because there's no point reading my book if you don't know English. I mean, you have to know, for instance, to give you an example, if I gave you a GIFT, would you be happy or not? You probably, because it means a present in English. But if you were Germans, I know there's some German people here, you wouldn't be happy because it means poison. I had a German friend tell me the first time he came to an English-speaking country, he thought we were all mad because we got poison shops everywhere. And that's why we have to have the right decoding machine. But the point is, proteins are very long strings of amino acids, and often tens of thousands of lengths long, and their order is specified by the letters in the DNA code. So what you have, first of all, in the DNA code is called transcription. They're amazing machines for transcription with a scrunching machine they just discovered, and that makes a photographic negative, in a manner of speaking, called messenger RNA. And then you have the 3 letters of the RNA making 1 letter of the protein. You see, and you've got machines. RNA polymerase makes the RNA, a very complicated machine, and what you have with the translation, the decoding, you've got these decoding units called transfer RNA, which links 3 letters to 1 letter, and you've got the ribosome, which actually puts it all together. And here is a huge problem for evolutionists, is that all this translating this machinery to decode the DNA is itself encoded on the DNA. But you can't read the DNA unless you have this machinery, but you can't get the machinery unless you read the DNA code. Furthermore, to read all this machinery requires energy, which means it requires ATP, which means you need to have the ATP synthase motor working better than I could get it working. But to build the ATP motor, you need the instructions on the DNA and all this machinery. So you see, life couldn't exist unless all this machinery was working together. It had to be already in place, otherwise life couldn't exist. And if you haven't got life, you haven't even got the beginnings of evolution by natural selection that Dawkins loves so much. So let's go through this animation. See, here's a DNA letter, as you could see. And here is a whole length of DNA here. And then you'll see in the background what's going to happen and be explained to you. Because there's a heat of that. There's the RNA polymerase racing down the DNA strand. And what it's doing is, here's the building blocks for the RNA. And it's been put together and shot out here. But you see how it actually unwinds the double helix, puts the messenger RNA on it, and then it has to wind back the double helix. There's quite a lot of amazing machinery to do this and not muck up your DNA in the process. There's one thing, and this is happening all the time in your cells, and see how then the messenger RNA floats off, and what's waiting for them is this machine called the ribosome. And here are the tRNA. This is again the link between the protein letters and the RNA letters. And here's the ribosome in action, which is requiring heaps of energy for every step. And here it is slowed down. You see how the tRNA is linking according to the code in the mRNA, and what it's doing is linking these protein letters one to the other. And every linkage step requires an ATP as well. So you see ATP is so heavily involved in what's going on there. Then we see the chaperones taking hold of it, so the protein doesn't misfold, because that's what mad cow disease is. It's a misfolded protein because the chaperones aren't working properly. So here's a problem for the evolutionists. I mean, how did all this happen before the chaperones evolved? Then you have the chaperone in the barrel-shaped molecule, yet another protein which helps to fold the protein, the new protein, into the correct shape. So you don't get mad cow disease, I hope, if these things are working well. So the thing is, you need chaperonins before a protein can fold. But how did the first chaperone fold itself without a pre-existing chaperone? See, yet another problem for evolutionists. And in fact, what we're doing here is showing how important information is. Now, you may have also heard about Craig Venter making synthetic life in a test tube. Well, I wrote an article about that. And the whole point is he actually just used the information from an already existing cell and put it into another cell and used that cell's pre-existing machinery. So he didn't really do anything. He used what was already there. And just to encourage you, here's another scientist, and probably not so smart as Venter, and this is what he says. If I could just synthesize life here, I'll have proven no intelligence was necessary to form life in the beginning. You'd be surprised how many people wrote to gloat about Venter's the creation of life, and they didn't see through this simple logic there, that it actually proved a necessity for design to make life. And he didn't use blind chance. Now here's an interesting thing about the information. Here's another person who is certainly no friend of Christianity, and he says most of the workings of the cell are best described not in terms of material stuff, hardware, but as information or software. Now how does stupid atoms spontaneously write their own software, he asks. Nobody knows. But evolution's a fact, though, he says. But he says there's no known law of physics able to create information from nothing. There's no law that would generate the messages that we find in the DNA for all these amazing machines that I've been pointing out. The laws of chemistry are against the origin of life. They're all going in the wrong way. For one thing, big molecules break down into little molecules. Now, proteins and DNA are very big molecules, but they just can't last very long. They break down. They don't build up. Even worse, in fact, water helps them break down. Now, was there much water in the primordial soup, do you think? I mean, as a chemist, I know if I want to make proteins, I get rid of water. So the laws of chemistry go against this idea of life from non-living chemicals. It just makes no sense at all. And this is what also converted Antony Flew to belief in a God of a sort. Unfortunately, I'm not aware that he converted to Christianity before he died. We reviewed his book in our Journal of Creation, by the way. Very interesting book, but he says, it seems to me that Richard Dawkins constantly overlooks the fact that Darwin himself pointed out that his whole argument began with a being that already possessed reproductive powers. This is the creature, the evolution of which a truly comprehensive theory of evolution must give some account. Darwin himself was well aware that he had not produced such an account. It now seems to me that the findings of more than 50 years of DNA research have provided materials for a new and enormously powerful argument to design. And this was the world's leading atheistic philosopher too. Now, one example of the amazing design, not only in the DNA, but the proteins that it codes for. Now, one of the main class of proteins is called an enzyme. Now, they speed up reactions. That's the main thing. And one amazing enzyme, which is involved in the machinery I've been talking about, speeds up reaction 10 to the power of 18 times. Be a pentillion, wouldn't it, I think? It's a lot of times. But he also explains that it would take only a fraction of a second in water with the enzyme, but 78 million years without the enzyme. The point is, you haven't got that long to evolve this thing because of the time it takes for proteins and DNA to break down. It would have broken down before it managed to evolve the right enzyme. So you just haven't got the sort of a time to wait for your building blocks to assemble. And this other one speeds it up to 10 to the power 21 times. So if we didn't have this enzyme, reactions would take much longer than the Big Bang age of the universe, which I don't even accept, instead of 100th of a second. So isn't this amazing? These hugely powerful enzymes which are coded in the DNA, but which are needed for the DNA decoding machinery to work. And this is what the discoverer said. He said, without catalysts, which include the enzymes, there will be no life at all, from microbes to humans. But then here is his blind spot. He says, it makes you wonder how natural selection operated in such a way to produce a protein that got off the ground as a primitive catalyst for such an extraordinarily slow reaction. Hang on, he's made a terrible blunder here, because here's what another evolutionist said. Dobzhansky, the leading evolutionist of the 20th century, some people say, he says natural selection is differential reproduction, organism perpetuation. In order to have natural selection, you have to have self-reproduction or self-replication, and at least two distinct self-replicating units. Pre-biological natural selection is a contradiction in terms. So you see the blunder by this chemist. I just wonder if he had to make a homage to evolution, whether he believed it or not. But the thing is, you won't have natural selection if you haven't got enzymes, because you won't have life. So natural selection cannot be the answer. And here's what really is the problem. It's a matter of a faith position these guys accept. A man called Hubert Yockey, he's a leading information theorist, and he wrote papers showing the impossibility of life from non-living chemicals, managed to get them published as well somehow. He said, research on the origin of life seems to be unique in that the conclusion has already been authoritatively accepted. What remains to be done is to find the scenarios which describe the detailed mechanisms and processes by which this happened. So basically, they already believe, before looking at the evidence, that life came from non-living chemicals, despite the amazing designs in even a simple cell. But he goes on to say that we have to conclude that the scenario describing the genesis of life by time and chance, which is accepted on the basis of fact and not faith, has yet to be written. In other words, they haven't got any scenario based on science, it's accepted on faith. And to give you one example of more things that you need for living things, think about the simplest free-living organism. There's no such thing as a simple organism. This mycoplasma has 482 genes. That's a huge amount of information, basically 500,000 DNA letters worth of information in a so-called simple cell. And yet, it needs to be a parasite. There's some things it can't make by itself, so it has to be a parasite on more advanced organisms. One variety causes pneumonia, for instance. They're not very nice creatures, really, but they have to be parasites to survive. And people who worked out what would be the simplest possible living organism, they've tried to say it might be 387 protein coding and 443 RNA coding genes. So that this is a so-called simple life, and they even say it's probably too weak to survive outside the lab. So you really wonder how this simple life could have survived in a harsh primordial soup, if it could even get there. And it's always a bit of fun to work out whether chance can do it. And I'll go through a few numbers here for you to try to work out the chance of one of these things forming by natural causes. So first of all, the estimates say there are about 10 to the power of 80. That's 1 followed by 80 zeros. That's the number of atoms in the observable universe. It seems like quite a big number, doesn't it? Then we can take the exaggerated figure, which is basically saying 1 trillion atoms interactions per second, which is far more than real life. But we're being generous to the evolutionists, allowing them this number of interactions, something coming together and forming something. Then you allow the Big Bang theory, which says 10 to the power of 18 seconds since the Big Bang, which I don't believe, but evolutionists need their time, don't they? So you've got this figure of 10 to the power of 110 interactions. That seems like a lot of interaction, but then you look at what's required. They say 20 amino acid letters. So you suppose that these 20 letters were in the primordial soup somewhere. But then you think of 380 enzymes for the simplest life that I mentioned. Now, the thing is, with an enzyme, or maybe not everything has to be exactly right. Our hemoglobin is not quite the same as ape hemoglobin. But even hemoglobin does have to be right so it can carry oxygen. So if we are very conservative and say that only 10 letters have to be right in every protein, which is just not possible actually, but this is being as generous as we can be. You get this figure here, if you do the maths, if you want to say the probability, a probability is a number between 0 and 1 inclusive. So here we've got a number of 10 to the power of minus 5,000. Or you want to say 1 in, 1 followed by 5,000 zeros, which is a number too big to even comprehend. But to make it easier for you, I'll think of your bank, your ATM cards, okay? What do you have to do? You have to guess a 4-digit number, and you've got 3 goes to guess that. Now that's supposed to be quite a bit of security for you, isn't it? Because there's 3 chances in 10,000 of someone guessing your PIN by chance. That's quite secure, supposedly. And your bank will say that if someone else guesses your PIN, it means you must have left it lying around for them to see. That's what the bank will tell you, because 3 in 10,000 is too small a chance. But let's look at this, though. This is like guessing a 5,000-digit PIN. I think a 4-digit PIN is hard enough. Try guessing a 5,000-digit PIN. This is the sort of probability for getting life from non-living chemicals, just by chance, because life is so finely designed with all the machinery needed. And in fact, I was being very generous, because some things like this protein calmodulin has 142 letters exactly specified. And just getting that protein alone is like 1 in, 1 followed by 185 zeros. That's the chance of getting just calmodulin by itself. One enzyme, let alone all the other 300 and something needed for living things. So you see that even the so-called simple living cell is just not possible for time and chance. But let's look at some other amazing designs and machinery that is not required for all life, but certainly it's used in our living things. This is a molecule kinesin. Now think again of your 100 trillion cells. This is inside your cells, to give you an idea of how tiny this is. And this is walking along these little railway tracks inside your cell. They're called microtubules, and it takes 125,000 steps per millimeter. I had to magnify it a bit so you could see it. And what it's doing, it's taking this bag of proteins from, so the inside to the outside of your cell or backwards. And again, it knows where to go because it's got these address labels on them. Okay, and also each of these steps requires an ATP molecule to give it the energy. So you need that rotary motor working before this one can work. So this is an amazing motor inside your cells, the kinesin, this walking motor of yours. So really quite an amazing machinery we have in our own little cells. But let's look at some larger things. For instance, I mean, we've got amazing breathing systems. Now, birds have a very special breathing system, as you might see, because you think of reptile and mammal lungs are like bellows. You see, we breathe in air, it goes in, and then we breathe out, it goes out the same way it came in. Now, birds have a very special, different system. They've got a system of air sacs, even including their bones, which make the air go through their lungs in a single direction. It's a totally different lung from the reptile lung. See, they say that dinosaurs evolved into birds, so instead of KFC, you should order KFD, shouldn't you? But the thing is, what we found of dinosaur lungs are totally different from what we find in birds' lungs. Even the Archaeopteryx, the supposedly transitional form, had a fully functional bird lung like this, which is hyper efficient because what you have is the air going in one direction and the blood going the other direction. And engineers know about this. It's called counter-current exchange, which means the blood picks up a maximum amount of oxygen. And we find this engineering principle all over the place in nature as well, this counter-current exchange. But one of the best examples is the birdie. So in this book by Vij Sodera, he talks about this, and he also says, well, how do you get the bird lung evolving from a reptile lung? Because what you'd have to do is have little hernia, basically. What they're saying here, what the evolutionists say, the earliest stage is in getting a bird lung from a reptile-like lung, which breathes through a diaphragm. You'd need to get a diaphragmatic hernia, a hole in your lung, basically. That's what the poor intermediate would have to look like, a poor creature with a hernia in his lung. And he says, in very fancy scientific language, that such a debilitating condition would have immediately compromised the entire pulmonary ventilatory apparatus. So what he's saying there, well, to go from a reptile lung to a bird lung, you have to get a hernia in your diaphragm, and how would this poor thing survive with such a thing? I mean, if you got one of those, you'd have to get operated on. You'd need surgery if you got a diaphragmatic hernia. And yet this is the intermediate stage between a reptile lung and a bird lung. The thing is, if a reptile lung couldn't evolve into a bird lung, then reptiles couldn't have evolved into birds. But the amazing bird lung design is something to behold. Now, what do the evolutionists have to offer? They really have got nothing to offer. But what they often do, and here's where the intelligent design people fall down, is they point out supposed bad design in things. Now, a lot of the bad design, apparent bad design, is the result of the fall. Now, Dawkins, in his book, says, well, look at these blind fish in caves. And he said, well, why would God make a blind fish? Well, of course, any biblical creationist knows God didn't do that. What happened is a sighted fish went into this cave and couldn't get out, but it's so dark you don't need your eyes in a totally dark cave. And therefore, any mutation which causes the eye to shrivel up would not be a problem. It would be a problem in the light, and natural selection would eliminate a blind fish in the light. In the dark, natural selection might even favor the blind fish because there's no eye to get infected. So, yeah, if you understand the biblical creation and fall model, you understand where blind fish came from. But Dawkins knocks down a straw man. Now, one of the other arguments for Dawkins is not based on ignorance of the biblical model, a willful ignorance, I might add, but a lack of understanding of the facts. And this is the famous backwardly wired eye that he's been talking about for decades now, and a lot of the evolutionists love this backwardly wired eye thing. Because the point is, to look at this diagram here, you see, what you have, the light's coming this way, but here you've got the rods and cones here which pick up the light and turn it into electrical signals, and what he whinges about is that the nerves go in front of the light, which does seem a bit strange, I will admit. And here is his case. He says, any engineer would assume that photocells would point towards the light and their wires would go behind them and lead to the brain. He would laugh at any suggestion the photocells might point away from the light with their wires departing on the side nearest the light. But this is exactly what happens in all vertebrate retinas. He says each photocell is wired in backwards with its wire sticking out nearest the light. The wire has to travel over the surface of the retina to a point where it dives through a hole in the retina, the so-called blind spot, to join the optic nerve. So the light has to pass through a forest of connecting wires, presumably suffering some attenuation and distortion, probably not much, he says. Making a lot of assertions here. He has no qualifications in optics or ophthalmology or engineering, but he's happy to speak for them all. But none of the people who make this argument really understand much about the stuff they're talking about. But see, in our Creation magazine, we had a good answer to that because we actually interviewed a professional leading ophthalmologist who's a researcher and teacher in eye diseases. And he said that this shows a lack of understanding of eye anatomy, what Dawkins says. It's a pity that Dawkins didn't actually consult people who knew what they were talking about. But so many of the athiopaths have just copied him and used the same arguments. Now, one thing you need, though, is this little thing here. This is a choroid, and this is the pigment layer. Now, what this choroid does is a very rich blood supply. because these rods and cones use up a lot of energy, and when they are hit by the photon, they actually change shape, and they have to be regenerated. How do they get regenerated? They need this blood supply, an extremely rich blood supply from the choroid, and the main regeneration part is this retinal pigment epithelium. So you had to put that blood supply somewhere. Where do you put blood? Now, what happens if you get a hemorrhage in your eye? It's very bad because the blood blocks the light so badly. So you can't put the blood here. You have to put the blood behind it, which means you have to have the nerves going in front, because if the nerves went behind, there'll be no room for the blood. And that means if you had a flash with a camera, it might be weeks before you could see again, with Dawkins' superior eye anatomy, because he forgets that you have to have a blood supply. But even more recently, they discovered that what we have is called the Mueller cells, which are actually optical fibers. This was discovered a few years ago, and they actually did experiments. This is actually what it looks like. In fact, they are optical fibers, a fiber optic plate that actually guides the light to the photocells without distortion. So in fact, what Dawkins says is that they must pass through all these nerves and get distortable. In fact, the Mueller cells take good care of that, and there is no distortion. And in fact, more recent work, only published this year, and it's on our website, is that in fact the Mueller cells do even more than that. They actually selectively transmit the visible wavelengths and keep out the UV and the IR, which we don't see, but it also cuts out reflected glare from light bouncing around inside your eye, because that reflected stuff doesn't get through the Mueller cells. Only the direct light gets through, but otherwise you'd spoil your image if you had a scattered light getting through. The Mueller cells stop that. It also stops chromatic aberration. That's what happens. See, all lenses produce a little bit of a rainbow effect, because a lens is like a prism. You know what prisms do? They turn white light into all the different colors. That's what raindrops do. This is what the lens of your eye would do, but this Mueller cell stops that. It collects all the colors and puts them back together again. So you've got a nice color vision, and also makes the image sharper as well. And the people who did this research say the retina is revealed as an optimal structure designed, what's that word again, for improving the sharpness of images. So the so-called backwardly wired retina, in fact, is an optimal design. None of this would be possible if it was the frontwardly wired retina that Dawkins thinks is so great. Here is actually the backwardly wired thing, which enables the Mueller cells to do their thing and improve your visual sharpness. So here's one of Dawkins' arguments is splattered by the real world of eye anatomy, you see. So here's a science catching up with the Bible, the one who said he makes the eye, the seeing eye and the hearing ear. And he did a very good job of it. That's why he talk about we have the eyes of a hawk, because a hawk's eyes are backwardly wide, but they see pretty well. In fact, our eye can see a single photon, a single particle, quantum particle of light, and you can't actually improve on that. That's as sensitive as you can possibly be. And the retina can detect a single photon of light. That's pretty amazing, I'd say. There are also some pretty amazing things about the sonar system as well, because you have a sonar system before we thought of it. In fact, it's interesting, even Dawkins himself relates the account of during the Second World War, the British scientists were developing top secret things like radar and sonar. And about the same time, they discovered that bats use sonar, echolocation. And they thought there must have been some security breach, that somehow it was a hoax, and these silly scientists were playing a joke and saying these stupid creatures had this advanced technology that we'd only just discovered and wanted to keep secret from the Germans. But now we know bats really do have amazing sonar system, echolocation. In fact, evolution doesn't help. The fossil people say that the oldest bat fossils belonging to an extinct lineage were unearthed from rocks about 54 million years ago, they date, but the creatures they represent aren't dramatically different from living bats. Hallmark features of these creatures include the elongated fingers that support the wing membranes and extensive coiling of bony structures in the inner ears, a sign they were capable of detecting the high-frequency chips used in echolocation. Isn't it interesting that bats have always been bats, just as the Bible says, that things reproduce after their kinds? There's no trace of evolution of the flying of the bats or the echolocation. Another statement said, again, for use in understanding the evolution of vertebrate flights, the early record of pterosaurs and bats is disappointing. Their most primitive representatives are fully transformed as capable flyers. Where's the evidence that these things evolved from non-flying creatures, as evolutionists say? It's just not there in the fossils. And the same with dolphins. Dolphins also have echolocation underwater, and in fact, it's better than the Navy system. The Navy are trying to learn from the dolphin. But again, what they say is the ancestor of today's dolphins had an ear structure that suggests they could echolocate as well as their modern relatives can. So where is the evidence that echolocation evolved? It was already there and fully functional right from the first creatures. Absolutely no evidence of any evolution. Now finally, one of my favorite things for design, to know whether something has been designed, try and make it yourself. And when we see engineers and scientists trying to copy God's designs, I think we know we're onto something. They're actually just borrowing the technique of the master designer. One thing is the way geckos stick onto ceilings. They can walk on polished glass upside down. It's because they have these very tiny hairs. You see how it's subdivided. The hairs are magnified, and here's one single hair, and the tip is even further subdivided. Very, very tiny. And what they do is make use of the van der Waals forces, which are very short-range attractions between molecules. Now, that's why it has to be so finely divided to make this sort of attraction. And this is incredibly efficient. And the people who thought this, they said it was beyond the limits of human technology. Later on, designers managed to copy it and make super sticky tape that was also self-cleaning, like the gecko's foot. Your ordinary sellotape, it picks up dirt and it's useless, but the gecko's foot is self-cleaning. So they managed to copy the design of the gecko foot to make this amazing super adhesive. Now, you might also have heard about these new airport scanners, and I hate to think what they're actually looking at, to stop the terrorists. Special X-ray scanners. Now, what they're actually doing is they're copying off the lobster eye, because a lobster eye is a very special thing. It actually focuses light by reflection. Now, our eyes focus light by refraction or bending light to a focus. And I see some of you need a bit of help to bend the light properly, with extra lenses, I mean. But a lobster eye doesn't need lenses because it uses mirrors instead. So here's a bit of a question. How do you evolve a mirror eye from a lens eye when they are completely different? The other thing about a lobster eye is it's got square facets. You look at the compound eye of a lobster, it looks like graph paper. It's square. But other compound eyes are hexagonal, six-sided. So how do you go from a six-sided to a square? Who knows? But what they've now done is use this lobster eye, this reflected focus, to make X-ray telescopes for one thing, but also airport scanners too, because they use the lobster eye running in reverse to make a parallel beam of X-rays to be used as an airport scanner, copying off the lobster eye. And here's another expert in biomimetics, Johanna Eisenberg, and she's talking about things like brittle stars, which are one compound eye. And what does she say about this amazing brittle star eye, where the entire skeleton's a compound eye? She says, this study shows how great materials can be formed by nature far beyond current technology. Arrays of micro lenses, something we tried a few years ago, and no one knew it existed already in nature. So nature, we can't do it, but the master designers managed to do it. And of course, the program for doing it in the DNA as well. Instead of unchangeable lenses, also the brittle star uses a channel system that pumps pigments to cover the lenses. So this is actually basically a natural sunglasses. So not only this amazing material technology to build this lens, but the natural sunglasses as well. And she's also researched things like the sponge flower basket, which turns out to be natural optic fibers. And she says the sponge uses all the reinforcement mechanisms that we know and use on the macro scale when we build buildings or bridge, but all in one structure and on a scale that's at least 1,000 times smaller. We're in the Stone Age compared to nature. The thing is that the sponge has such great fiber optics, you could also tie them into a knot. You know about fiber optics as a great way of signal transmission, better than copper wires. The problem is they break easily because you have a crack. It's made of glass. Glass can be quite brittle. And the reason glass is brittle is because once you have a crack in the glass, it'll propagate through the whole thing. But what you have with a sponge is concentric layers building up the sponge fiber optic. So when you have a crack, it gets stopped at the layer boundary. So it's actually so flexible we can tie it to the knot. That's why it's such a much better system. Also, it's made cold too. To make a glass fiber optic, you need the melting point of glass. The sponge, a so-called primitive animal, uses seawater temperature. And more recently, we found that the way cuttlefish change color has inspired a super efficient TV screen using the same principles that a cuttlefish uses. So again and again, we have this area called biomimetics, where humans are copying from God's design in nature. And it's a shame that a lot of them don't give credit to the master designer. But recently in our Creation magazine, we had an interview with Professor Stuart Burgess, who leads the biomimetics group at the University of Bristol in the UK. So here's one expert in biomimetics, a world-class expert who does give credit to the designer. And one of his things, he's making micro-flying machines based on dragonfly flight. So many things that human designers are only just beginning to learn. Now, there's much more I could be saying, and a lot of that's actually in my book called By Design, about both the microscopic and the large-scale designs of eyes and ears and super materials. The best rubber is actually found in nature, and how shells can become and teeth become so tough. They're made of brittle material, but they're really tough because of the way they are organized. I mean, your tooth enamel supposedly has defects called tufts in them, but in fact the defects actually stop the cracks propagating, which is why your tooth enamel is so tough, even though it's made of a material as brittle as glass. Going back to Dawkins, he says, although atheism may have been tenable before Darwin, Darwin made it possible to be an intellectually fulfilled atheist. He needs evolution for his atheistic faith. It's his crutch. That's why we are supposed to demolish arguments and every pretension that sets itself up against the knowledge of God, and we take captive every thought to make it obedient to Christ. That's what we are supposed to be doing. That's why we've got all these resources. That's why we have these conferences. We want to help you defend the faith and turn the world around. So thanks very much again for coming to this conference and for listening to me. We'll see you back here for the panel.